In this podcast, we're going to take a look at limiting reactants. The basic idea about a limiting reactant, or sometimes you'll see it called a limiting reagent, is trying to figure out which reactant is going to limit how much product you can actually make. In most real-life cases, you don't have exact perfect ratio of all your ingredients or all your reactants in order to make the maximum amount of product. Something's going to run out first. So if we look at this picture as an example, if I'm trying to build cheeseburgers and I have some hamburger patties, some hamburger buns, and some slices of cheese available, if I don't have a perfect ratio of all my ingredients, one of them is going to run out first, and that would limit the amount of product that I can make. Based on the picture you see here, you can see that I ran out of the hamburger patties first. I was able to make 3 cheeseburgers, and then there were some other reactants that were left over. Anything that's left over is called an excess reactant. At whatever point we run out of one reactant, product production stops, and that tells me how much product I can make. Now, when I have big, giant pieces that I can see, it's real easy to count up how much can you make, how much stuff is left over. When we're talking about individual atoms and molecules that we can't see, we're going to have to do some math to figure out which ones run out first and how much product we're able to make as a result of that. So here's an example, kind of walk through the process of what these calculations are going to look like. The steps to figuring out first which of your reactants is the limiting reactant. First thing you'd have to do is make sure you have a correctly balanced equation first. Some questions will give you a balanced equation, others you'll have to write it and balance it yourself. Then your reactants need to be in moles. If they're not given to you in moles already, make the conversion to get them into moles. Take each of those mole numbers and divide them by the coefficient for that reactant in the balanced equation. Whichever answer is the smallest at this stage tells you what your limiting reactant is. Now, this sounds more confusing than it is. When we walk through an example, we'll see this. From this point, once you've identified the limiting reactant, the rest of what you do depends on the question. To figure out anything else the question could ask, you start with the original amount of the limiting reactant. That's your starting point for any kind of regular stoichiometry problem to calculate whatever you're being asked. The kinds of things you would typically see would be how much product can you make, or how much of another reactant would you need, at what point the reaction stops. So everything you do is based on how much limiting reactant you have. So you have to be able to identify that limiting reactant first. The rest is the math that you've already done. So let's walk through an example. Rocket engines use a mixture of hydrazine, which is N2H4, and hydrogen peroxide as a propellant, which would be the limiting reactant if I have 750 grams of the hydrazine mixed with 500 grams of the hydrogen peroxide. And then once you know what the limiting reactant is, how many grams of this product, water, am I able to form? So 2 very typical questions. First thing you'd have to check for is a correctly written and balanced equation, and in that question it was given to you. Next is to convert those reactants into moles. So my 750 grams of hydrazine divide by its molar mass. Same thing for the hydrogen peroxide, divide by its molar mass. This now gives me my reactants in moles. Divide each of those moles by the coefficient that the corresponding substance had in that balanced equation. The hydrazine had a coefficient of 1, so I'm dividing the 23.4 moles I got here by 1. The hydrogen peroxide had a coefficient of 2 in the equation. So I'm taking the 14.7 moles I calculated and dividing by 2. This is the stage where I compare these 2 answers. Whichever one is the smallest tells me what my limiting reactant was. Since the hydrogen peroxide gave me the smaller answer at this stage, that tells me that hydrogen peroxide was my limiting reactant. That means any other question, anything else I do from this point on, starts with the hydrogen peroxide number. So I'm going to use that original amount of my limiting reactant to calculate what the question asked, which in this case was how many grams of water I could make. So now this looks like a regular stoichiometry problem, like we had done previously. I take my original amount of the hydrogen peroxide that was given to me in the question, since that was my limiting reactant, and now I'm doing a 3-step stoichiometry problem aiming towards how many grams of water am I able to make. So everything else should be familiar steps, changing from grams to moles, mole ratio for my balanced equation, and then changing moles back to grams. Multiply the top, divide the bottom, and in this case you should get about 530 grams of water. Let's walk through one more example. If I've got 20.5 grams of chlorine reacting with 20.5 grams of sodium to form sodium chloride, which reactant is limiting, which one is excess, and how many grams of the product can I make? In this case, I didn't give you the balanced equation, so that's going to be your first step, is to write out and balance the equation. Don't forget to watch for Hunkelbrief members. Chlorine, when it's alone, should be diatomic, which means when I balance the equation, this is what I've got. Next, to figure out what my limiting reactant is, I'm going to take my reactants, which were both given in grams, that's pretty common, and change them from grams to moles. So these should just be one-step conversions, divide by molar mass. That'll give you how many moles. Then you take each one and divide by its coefficient in the balanced equation. The chlorine had a coefficient of 1, the sodium had a coefficient of 2. Then I can compare these two answers to see what my limiting reactant was. Chlorine was the smaller of the two, so chlorine is the limiting reactant. Sodium gave me the larger of the two answers, so sodium is the excess reactant. Now I can figure out how much product I'm able to make. I do that by starting with my original amount of the limiting reactant. So since chlorine is limiting, I'm going to start with my original amount of chlorine and calculate how much product I can make. My original amount of chlorine was 20.5 grams, so now I'm back to a regular old stoichiometry problem going from grams to moles, mole ratio from my balanced equation, moles back to grams, and I was aiming for the only product in that reaction. If you do all the math, multiply the top, divide the bottom, it does come out to 33.8 grams of the sodium chloride. Now one for you to try. Follow the exact same steps. Here's your problem. I'll give you a balanced equation. It's balanced already. 28.8 grams of hydrogen reacting with 55.8 grams of nitrogen. You need to figure out what the limiting reactant is and how many grams of product you'll form. This last question here is a little bit of an extra challenge. If you can figure out how to do this one, you are in really, really good shape. That is definitely the bonus challenge. So give it a try. Pause the podcast. You should definitely be able to answer the first two questions. And if you are an extra special rock star, you should be able to answer the last one. Give them a try and then we'll walk through it. First thing you check for is balanced equation, and I gave you an equation that was already balanced. Next, you take your amounts of your individual reactants and convert them from grams to moles. So that's what you see here. Then you take those number of moles and divide by coefficients from the balanced equation. So the hydrogen got divided by 3, the nitrogen got divided by 1. I compare my two answers here, and that tells me that nitrogen is my limiting reactant. That means anything else I calculate from this point on has to start with my original amount of nitrogen. This will be the beginning for anything else I do now. Next question asked is how much product I'm able to make. So this is a regular stoichiometry problem, starting with my original amount of the limiting reactant, change it from grams to moles, mole ratio from the balanced equation, aiming towards the product, and then molar mass of my product here at the end. Multiply top, divide the bottom, you should have 67.8, there's an extra decimal there, 67.8 grams of the NH3. Now the extra special challenge was to figure out how much of the excess reactant was left. Well, you hopefully identified that hydrogen was the excess reactant. So to see how much of it is left, you would first need to know how much of it you actually used. So like any stoichiometry problem, like any problem we're doing here, start with your original amount of the limiting reactant. Only this time, instead of aiming for the product like we did up here, you're aiming for the excess reactant to see how much of it you actually needed. In order to use up all 55.8 grams of nitrogen, you needed to use 12.0 grams of the hydrogen. Then you could look at the original question and see I had 28.8 grams available. Looks like I typed my 0.8 twice here. So you had 28.8 grams of hydrogen available from the original question. I only needed to use 12 grams. At that point, my nitrogen was gone. So if I subtract those two, that tells me how much hydrogen should be left over sitting there at the conclusion of the reaction. If you can do this, you can answer anything I could ever possibly give you. All finished.